In this video, I'll show you how to make a process control chart for a categorical variable, known as a P-chart. The question reads, make a control chart for the proportion of defective light bulbs coming off a certain production line. The first step is to choose a sample size n and the testing frequency. For this, we'll use a sample size of 1,000 bulbs every day for 21 days. So, as the quality control personnel, you will be looking at the 1,000 bulbs built in that day for the next 21 days. Next, you'll collect the data and you will count the number of defectives in each sample of the 1,000. So for example, on day 1, I found out that there were 63 defects. 63 divided by 1,000 gives me this decimal. And I can easily find the percentage by multiplying it by 100. The formula for this is shown right here, where the proportion of defects is equal to the defect divided by the sample size. Once you fill in your chart, you should end up with something that looks like this, and you want to calculate the total defects over the 21 days. This column will serve as your vertical column in your XY chart, whereas the days will serve as the independent variable, the x-axis, which is the horizontal axis. I've gone ahead and plotted this. Notice that days occurs along this axis and the proportion of defects, not the number of defects, is on the y. The next thing I'll do is compute the average proportion defective, which I'll denote as P bar. So P bar is equal to the total of 1,464 defects divided by the total amount, which was 21,000. Let's use our calculator to find the percentage here and the decimal. So 1,464 divided by 21,000 gives me a value of 0.0697 or 6.9%. And you can round that up to 7. The next thing that we have to do is compute the standard error, which is represented by SE for standard error subscript P. The standard error for a proportion in which the probability P of success of a single event is given by this formula. But unfortunately, we don't have the exact probability. And in fact, it would probably be impossible to find that. So instead of using the actual probability, we'll use what we know, which is P bar. With that said, the standard error is equal to the square root of P bar, which is 0.0697 times 1 minus 0.0697 divided by n, which equals to 1,000. That was the amount of light bulbs tested on a daily basis. Using our calculator, the square root 0.0697 times 1 minus 0.0697 divided by 1,000 gives us the following standard error, which is equal to 8.05 times 10 to the power of negative 3. So 0.00805. And this can be rounded to 81 at the very end. Next, we have to choose a confidence interval. We have three options. We can choose a confidence interval of 98, 95, and 68. We will use 3 sigma limits, which are the most commonly used in the industry. So to do this, our upper limit will be defined as P bar plus 3 times my standard error, which is right here. Remember, if we're using 98, we do 3 times. Magnitude of 3, 0.00805. And similarly, our lower limit will be defined as P bar minus the same thing. Using our calculator now to compute these, we have P bar of 0.0697 plus 3 times 0.00805. That gives us 0.0939. 0.0939, approximately that. Doing the same thing here, I'll simply switch the plus to minus. And that gives me 0.0455. Let's continue. Next, we have to draw at P the upper and lower limits for the chart that we created earlier. So let's go ahead and do that. I'll use my straight line tool. So we had an upper limit, if you recall, at 0.0939. So that's around there. And we had a lower limit at 0.0455, which is going to be over here. Now, of course, if you're doing this more accurately, you would want to use better intervals along the y-axis, although this is good enough for demonstration purposes. Let's continue. Shown here is a more accurate drawing between the relationship of a normal curve and the control chart. Note that the upper and lower limits are placed at 3 standard errors from the mean, so that there is a 99.7% chance that a sample will fall between these limits. So there you have it. That is how to make a process control chart.